Welcome to AI Frontiers, where we explore breakthrough research in artificial intelligence. Today, we're diving into 15 remarkable papers from June 26, 2025, all from the computer science artificial intelligence domain. These papers showcase cutting-edge advances spanning efficient reasoning systems to large-scale social simulation, human-AI collaboration, and safety alignment. What makes this collection particularly fascinating is how these individual breakthroughs collectively paint a picture of a field in transition, moving from brute force approaches toward more elegant, human-inspired solutions that challenge everything we thought we knew about intelligent machines. Picture this scenario. It's a Tuesday morning in 2025, and somewhere in a research lab, an artificial intelligence system is playing Sudoku. But this isn't just any AI system. It's solving complex puzzles using only 27 million parameters and just 1,000 training examples, achieving near perfect performance. Meanwhile, across the globe, another AI system is orchestrating the daily lives of 53,000 virtual citizens in a simulated city. Each digital citizen has their own beliefs, goals, and quirky habits, making decisions that feel authentically human rather than mechanically perfect. These aren't scenes from science fiction. They're real breakthroughs happening right now in artificial intelligence research, demonstrating capabilities that seemed impossible just a few years ago. The field of artificial intelligence is experiencing a fundamental paradigm shift. We're witnessing a transition from massive-scale approaches toward more elegant, human-inspired solutions. Research teams around the world are tackling fundamental questions about intelligence, reasoning, and interaction. Some are building AI systems that can understand and navigate our complex social world, while others are creating agents that can improve themselves through experience. What unites all this work is a shared ambition to push beyond current limitations and create AI that's not just more powerful, but more thoughtful, more collaborative, and more aligned with human values and needs. To understand where this research fits in the broader landscape of artificial intelligence, imagine AI research as a vast archipelago of interconnected islands. Each island represents a different approach to creating intelligent systems, connected by bridges of shared techniques and common goals. On one island, researchers focus on making machines understand human language with all its nuances and contradictions. On another, teams work on helping AI systems navigate the physical world, learning to see, move, and manipulate objects like humans do. There's an island dedicated to reasoning and problem solving, where researchers try to capture the essence of logical thinking in computational form. What's exciting about today's research is that we're seeing more bridges being built between these islands, representing hybrid approaches that combine insights from multiple areas of cognition and behavior. The first major theme emerging from this research is urban and social simulation, representing the ambitious attempt to model human behavior at scale. Think of this like creating a digital twin of society itself, complete with all the complexity, unpredictability, and emergent behaviors that characterize human communities. CitySim and Mobiverse represent groundbreaking work in this area. CitySim creates virtual cities populated by AI agents that exhibit realistic daily routines, personal beliefs, and long-term goals. These aren't simple rule-following robots, but agents that can adapt their behavior based on circumstances, maintain consistent personalities over time, and interact with each other in ways that produce genuine social dynamics. What's remarkable about this work is how it captures the messy reality of human behavior, where people have preferences, moods, and habits that influence their choices in ways that seem authentically human rather than mechanically perfect. The second theme is advanced reasoning and problem solving, which gets to the heart of what we mean by intelligence. This is like trying to reverse engineer the human mind's most sophisticated capabilities, including the ability to break down complex problems, see patterns across different domains, and construct logical arguments. The hierarchical reasoning model represents a fascinating approach to this challenge, drawing inspiration from neuroscience to create AI systems that think more like humans do. Instead of processing information in a single monolithic way, this model uses multiple levels of abstraction operating at different timescales, much like how our brains handle both immediate tactical decisions and long-term strategic planning. It's like having a cognitive architecture that can simultaneously manage detailed problem-solving steps while maintaining awareness of broader objectives and constraints. A third prominent theme is human-AI interaction and collaboration, addressing how AI systems can work effectively alongside humans. This is like designing perfect dance partners who can anticipate our moves, complement our strengths, and compensate for our weaknesses. The research in this area recognizes that the future of AI isn't about replacing humans, but about creating systems that enhance human capabilities and work seamlessly with us. Safety and alignment form another critical component of this theme. As AI systems become more powerful and autonomous, ensuring they behave safely and beneficially becomes paramount. The research shows over 20% improvement on indirect harm scenarios and an average win rate exceeding 70% against strong baselines on existing safety benchmarks. This represents progress toward AI systems that can anticipate the long-term consequences of their actions and advice, which becomes increasingly important as AI systems influence high-stakes decisions in healthcare, policy, and other critical domains. The key findings from this research are reshaping our understanding of what's possible in AI. Perhaps the most striking breakthrough comes from the hierarchical reasoning model, which achieves exceptional performance on complex reasoning tasks using only 27 million parameters and 1,000 training samples. To put this in perspective, most current large language models use billions of parameters and require massive datasets for training. It's like discovering that a small, well-designed engine can outperform a massive, fuel-hungry motor. The model operates without pre-training or chain-of-thought data, yet achieves nearly perfect performance on challenging tasks, including complex Sudoku puzzles and optimal pathfinding in large mazes. In spatial reasoning, researchers discovered that existing vision language models exhibit near-random performance when forming spatial mental models from limited views. However, a synergistic map-then-reason approach boosted accuracy from 37.8% to 60.8%, with reinforcement learning pushing performance to 70.7%. Meanwhile, urban simulation results show CitySim successfully modeling tens of thousands of agents exhibiting realistic collective behaviors, while Mobiverse efficiently manages approximately 53,000 agents on standard personal computer hardware. For our paper of the day, we focus on CitySim, modeling urban behaviors and city dynamics with large-scale language model-driven agent simulation. The researchers behind this work, led by Bougie and colleagues, weren't just trying to create another simulation tool. They were attempting to capture something as complex and unpredictable as human nature itself, then scale it up to entire cities. The challenge they faced is profound. Traditional urban simulations rely on rigid, handcrafted rules that treat people like predictable automatons. But anyone who's lived in a city knows that human behavior is anything but predictable. We have moods, preferences, and habits that influence our decisions. We adapt to changing circumstances, pursue long-term goals, and sometimes act in ways that seem completely irrational. The researchers' solution was elegantly ambitious. They decided to use large language models as the brains of their simulated citizens, with each agent generating realistic daily schedules using a recursive, value-driven approach. CitySim's technical innovation rests on three key pillars that enable realistic behavior simulation. The recursive, value-driven scheduling system allows agents to plan their activities by considering multiple factors simultaneously. mandatory activities that agents must perform, personal habits that reflect individual preferences and routines, and situational factors that require adaptive responses to changing circumstances. The belief system enables agents to maintain consistent worldviews that influence their behavior over time. This isn't just about storing information, but having perspectives and opinions that shape how agents interpret new situations. The long-term goal framework ensures that agent behavior exhibits coherent patterns rather than random variation. An agent might have a goal of staying healthy, which influences their choice to walk to work instead of taking public transportation, or a goal of social connection that leads them to frequent certain community spaces. Additionally, spatial memory enables realistic navigation through the urban environment, allowing agents to learn and remember locations while developing preferences for certain routes and destinations. What makes CitySim's results truly remarkable is how individual agent behaviors aggregate into realistic collective patterns. The simulation naturally reproduces rush hour patterns, weekend versus weekday activity differences, and seasonal variations in behavior. These weren't programmed explicitly, but emerged from the interaction of thousands of individual agents making personal decisions based on their own preferences and circumstances. The researchers conducted extensive experiments modeling tens of thousands of agents simultaneously, evaluating their collective behaviors under various real-world scenarios. They tested the system's ability to estimate crowd density in different urban areas, predict the popularity of various locations, and assess overall population well-being metrics. Urban planners can use CitySim to test the potential impacts of proposed infrastructure changes, policy modifications, or development projects before implementing them in the real world. Social scientists can conduct controlled experiments on urban populations that would be impossible or unethical to perform with real people, exploring questions about economic stress, community cohesion, and social integration in a safe, systematic laboratory environment. Looking toward the future, these advances point toward a convergence horizon where AI systems become increasingly integrated into the fabric of our daily lives. Think of it like the development of the telescope, which didn't replace human curiosity about the cosmos, but dramatically expanded our ability to explore and understand the universe. The trajectory of this research suggests we're moving toward AI systems that are more collaborative, more contextually aware, and more aligned with human values and needs. The urban simulation work points toward better city planning and policymaking through realistic behavior modeling. The reasoning advances suggest AI assistants that can help us think through complex problems more effectively using human-like cognitive architectures. The embodied intelligence research paves the way for robots that can work alongside us in physical environments. Perhaps most importantly, this research is revealing new insights about intelligence itself, both artificial and human. By trying to recreate human-like reasoning, spatial understanding, and social behavior in machines, researchers are developing deeper theories about how these capabilities work in biological systems. As we conclude our exploration of these groundbreaking papers, it's clear that we're witnessing a pivotal moment in AI research. The field is maturing beyond the early focus on raw performance metrics toward more nuanced questions about collaboration, safety, and real-world applicability. These researchers aren't just building more powerful systems, they're building more thoughtful ones. The 15 papers we've explored today represent thousands of hours of careful research, experimentation, and innovation from teams around the world, each contributing pieces to a larger puzzle of understanding intelligence and creating beneficial AI systems. From the elegant efficiency of the hierarchical reasoning model to the rich social dynamics of CitySim, from the spatial reasoning breakthroughs to the safety alignment advances, each paper adds something valuable to our collective understanding. What strikes me most about this collection is how it balances ambition with responsibility, with researchers pushing the boundaries of what's possible while carefully considering the implications of their work. This content was synthesized using GPT Anthropic Claude Sonnet 4 2005-0514, with text-to-speech synthesis via OpenAI and image generation via Grok. Human expert review was conducted for accuracy, though some oversights may exist. All references are provided for further exploration. The research we've discussed today represents the collaborative efforts of global teams working toward beneficial AI development. These advances demonstrate that the future of artificial intelligence lies not in replacing human intelligence, but in creating systems that enhance our capabilities and help us understand our world better. The integration of reasoning, perception, and social understanding capabilities suggests we're moving toward AI systems that can work alongside us as sophisticated partners in solving complex challenges. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.